Hey everybody, so we're going to talk about harder, better, faster, stronger. So this is how you create a song if you're Daft Punk. So mostly about SQL injection and one, like imagine you get a big vulnerable, a big SQL injection and how you can retrieve a huge amount of information really fast. Let's say you want to dump, I don't know, all the users from the PSN network. And you say, oh, how can I do it in a really effective way? So that's what we're trying to do today.
Yeah, so first, just a bit about us. As you heard, we work for Securus Global, based out of Melbourne, me and Louis. We do a lot of web pen testing, but also looking to other areas, like testing WAFs and scanners and things like that. It's pretty good.
Yeah. Enjoying the Melbourne weather, this kind of stuff. Yeah. So, what do you want to improve, like to optimize all your SQL injection? First, to be really fast. If you're dumping a lot of information, it can take hours. So, if you manage to get one request instead of 3, you will win a lot of time. So, that was the first reason. Yeah, it's. Yeah, I don't know.
Also, like stealth. Like, if you can reduce the query length, you can you'll be able to exploit some vulnerabilities that other people won't be able to. And yeah, SQL maps kind of slow and pretty dodgy. So that's saying better.
And that way, like if you're using SQL map, it's pretty much too easy. You just have to do like ./SQL map. So why? Just not, you can write a script and take hours to write a nice script and make it work, and it's a bit more fun instead of just using like tools that do everything for you. And it's fun.
Yeah. So those are the main points we're talking about today. Yeah. Start off with the length of the injection, things you can do there, like losing white space, and then yeah, we have 2 different ways of speeding things up as well. Either like retrieve, like make it so you have to retrieve less information, but you'll still get the same result, or just getting more information out of a request. It's kind of hard to explain, but you'll see soon.
Yeah.
Yeah. Okay. So first, some functions, just function aliases. The most common substring. As you can see, mid does the exact same thing, same parameter, argument order. Works pretty well. Not detected by WAFs as much as well. It's kind of good. And after you've like retrieved a lot of data, you kind of want to make sure it's like if that's actually what's stored in there, like there was no mistakes or like the scripts actually worked. So a shorter way to do that is either use like a checksumming function like CRC32 or MD5, and that'll make it a lot shorter because you don't actually have to have the entire data in the actual query that you use to check the information.
So there's a lot of little tricks as well that can be used either to like have a shorter payload or just to bypass as well WAF. Like since most of the WAFs are using regular expression, if you do the same thing but a little bit differently, you may be able to bypass them. So this is just like some really basic stuff. Select at version without a space here instead of doing select space version. If your WAF is checking for select space something, you will be able to bypass it. And here you can win like it's 1 character less, smaller. Same thing for instead of doing and space 1 equals 1, you just do n1 or n1. It works as well.
But yeah, down the bottom, doing or 1, the bitwise operator, I guess. You can do it for everything or work the same except for null. That won't return true, that will return null, which will be false. So it's kind of a bit of a gotcha, but works most of the time. And yeah, there's some really basic tricks as well. Like anyone who's done any like scripting and programming, you'll know these straight away. Like yeah, using exclamation mark is not. It's 1 character, it's really short, works well. And then instead of doing less than or equal to or greater than or equal to, just flip the order, and you can change the sign, and it's kind of handy, 1 character. In
the same way, like if you're retrieving information, why you can use for MySQL compression function, like compress. However, you have to know like when it's worth it. For example, if you're compressing the word admin, the length of admin is 5 characters. So if you retrieve 1 bit of information, if you need 7 bits of you got 7 bits of information, 5 times you need 35 requests. But if you use compress here, you will need more requests because the length of compressed admin is bigger than the length of admin. So here it's not worth it. But if you need to retrieve a huge amount of the information, like we took this like a big database of CVE, put that in a database and try to retrieve everything. And based on the size of what we were trying to retrieve, see, should we use compress or should we just use the length? Should we use the string as if? So if, for example, here in blue you get the length of the string and in red the length of compress of the string. So until you hit the 80 characters, it's not worth it to do compress. But after, if you have a lot of information to retrieve in one request, using compress is really worth it, especially once the size of the information increase and increase.
Yeah, it's about twice as fast once you get like some decent size strings. So.
The problem is that you will need to be able to create that long string. So what you can do is using concat WS and put all the columns together. So instead of just saying, select ID from users, you will do like, concat WS, ID, name, age, address, password, and it will just make everything one string. So after you can compress it, so you get the long string you can compress.
An important point as well is when retrieving the bits from a byte for a character kind of thing, you only retrieve the 7 of the 8. Like most of the time you don't have to worry about the first one. But when you're using compress, you do have to care about all 8 bits. So you've got to be careful there.
And in the same way, you can use group concat, which is a really interesting function in MySQL that will take the rows in your result and put them together. But there is a big limitation at 1024 characters. So you have to be aware of that. But it's really worth it most of the time because you will have only one request. For the same thing is that if you're using, if the information change a lot, like a MD5, all characters will be really, really different. Compress will generate a bigger string than just using the string on its own. So it's not really worth it. It's when the data looks the same, but it's interesting.
But yeah, if you use the function onHex on hex data, then yeah, it becomes really simple. It's a shorter string. But yeah, once again, you have to retrieve all 8 bits, just like the compress. And yeah, it's 128 requests instead of about 300, so it's a lot faster.
And same thing, a lot of tools, when they're trying to retrieve an integer, they just take the integer, transform it as a string. And that takes a lot of requests as well. I think SQL Map does that. So it's like, here it's 3 bytes, so you need to do 21 requests. If you use 131 as an integer, you just need 8 requests to get the information. It's a good thing.
Just when seeing any type of data, if there's some things some constraints, that'll speed up your requests and your retrieval information.
And since it's an integer, you can do dichotomy search. So you will just split the space in 2 and say, is it greater, like you're looking for 7, you'd say, is it greater than 10? No, it's not. So, it's probably between 0 and 10 and 9. So and after you go, it's bigger than 0. Yes, it is. So you split into the space again, and that way you got a really fast search.
You can also use the function conv. That's just changing between bases for numbers. So like the idea here is that you take 131, you'd convert it to base 2, and then get the length of that, and that'll help with the retrieval information. It kind of sucks for small numbers, but once you get into large numbers, it becomes worth it. Yeah, this is a cool trick. No scanners I've seen are doing things like this, but if you take like creating injections or tests for injections that cover a lot of scenarios in a single injection, yeah, you'll get results. But I think like all scanners should do this like for the first request to test things. But after that, you need to get more granular and see exactly where the vulnerability is. But it can make finding vulnerabilities faster, but then you still need to do the extra work so you don't miss any, like false positives, I guess.
Because like if here, for example, your payload is injected into an SQL query and it's an integer, you will hit that case. If it's a string using quote to, as a separator for the string, you will hit that case because the dash dash will comment out the end of the query. And if it's a string using a double quote, you will hit that case, and this will be the normal string, and this will be the injection. So that way, using only one string, you cover all these cases, and if you see a weird behavior in the response, you're likely to have found something. So another thing is, instead of limiting the number of requests you will do, you will try to guess what the next response is going to be. So what is often used, like when you're cracking password, is Markov chain. It's like you take a lot of words and you learn. So if I got an E in English, the letter that is the more likely to be after the E is maybe a S. So we're going to use that. Oh, I just retrieve an E. So I'm going to try is the next letter a S? If it's a S, I win, and I just have to do one request. If it's not, I have to do the 7 requests to retrieve 1 byte of information again. So what you do is that you create a big dictionary of all table name, column name, and information you want to gather. And you learn on all this information, and after every time you try to get a new byte of information, you try to guess before trying to retrieve it, so that way you can win few requests. Fortunately, it doesn't work really well. So what you can do as well is either by learning from the same dictionary or when you're retrieving information, you can build a tree of all the words you're using. So instead of, with Markov, you just say, oh, I got that letter, what the next one is likely to be. With that, you will say, oh, I got all these letters. I got, like, for example, RUX. What's the next letter is likely to be? And here it's a C because it's Ruxcon. And that works heaps better. So when you're learning, you say, oh, first I got an empty tree, and I'm inserting Ruxcon. So Ruxcon, and each probability going to be 1. After, I'm going to insert Ruxmon, UX6, and here it splits the tree, and I'm as likely to get a C and an M. I keep doing it. I insert Russian, AUX, so I've got 2 chances to get a X and only 1 chance to get a S. And that way, using thousands and thousands of words, I can build my tree, and when I will try to retrieve information, I can guess the next bit of information. So for example, I just retrieve RU from the first request, and now I will try to guess, oh, what the next letter is likely to be. And bang, oh, it's X, because during my learning process, I know that when I train my tree, and I tell him, oh, when you got RU, the most likely next letter is X, and that works really well. So if you don't do any optimization, so based on this is dumping all the column names from a database, you will do like 3,000 requests. If you use Markov just by saying, oh, what's the most likely next letter, you go down to 3,100, which is like okay, but not really good. What you can do, a good optimization, is use lowercase, because most of the time you don't care about the case of the information you're retrieving. So it's a little bit better. If you use a tree, you go down to 1,000 and 200 requests, pretty much. So it's really, really effective. Imagine you have to dump a lot of information. You're going to be 3 times faster. And the thing is that it doesn't really change the algorithm of your SQL injection tool. It can be pretty easily incorporated in SQL map. Unfortunately, SQL map is in Python, so I'm not going to code it. But yeah. And yeah, another way is here, what we did is just, we learn from a dictionary and after use the remote database, but what you can do is learning during the process. Oh, I just dump Ruxcon. Maybe I will learn from Ruxcon because in the database, the user are likely to use the same name for table, column, and this kind of thing. And as well, it's really good to detect prefix because, when you, for example, most of the open source project, when you install them, they ask you for a prefix for the database. So you will say, WordPress _ something. If you manage to detect the prefix every time, you're going to be really, really faster because all the tables' names are going to have the same prefix. So with that, you can do it pretty quickly.
Okay, so here we have a pretty common SQL injection. Like the developers have tried to do the right thing, try to use an escaping function, but they've screwed up because it's in an order by. It's not wrapped in backticks, but even if it was, it's not going to help there. And yeah, it's a tricky one, still catching a lot of people out.
Yeah.
So we thought it'd be a good one to try and find some really specific optimizations here, like not just general strategies, but like if you come across this, what's your best attack kind of thing.
Right.
This is showing your injection here for that case. You could just like blindly check each character using subqueries. Like, is the first letter A for something? Is it B? Go on like that. You could also use a binary search algorithm. That'll speed it up a bit. But here we have an example. On the version, just checking each bit individually. It doesn't really make sense on a string to do that. Because it's really only going to be like even version, you have a fair bit of idea about what the format's going to be. But if it's like compressed data, then checking every bit's going to be quicker than binary search algorithms or things like that. That's
pretty much
basic.
so. That's the worst way to do it. That what I don't know everyone is using at the moment. Pretty much, including SQL map, I think. The thing is that relies on the fact that it's a blind SQL injection, and people think, oh, it's blind SQL injection, I got 2 states, but here you're ordering information. So since you don't have true false, you have information order in a different or sort in a different order. You can use that to generate more states. So here, for example, let's say that we can order information using 4 different columns. You can generate 4 states instead of 2. So you can, instead of getting 1 bit of information, you can get 2 bits of information per request. And in the same way, what you can do is sort by more than 1 column. So you order by a first column and after by another one. So you generate even more states. So you can retrieve even more information.
You can take that a step further as well. If you wrap the field name, order by field name, if you wrap the field name part inside an if, and then if the case is true, order by that column, otherwise order by null, and then ascending or descending, then you can also play with the direction of the data that's ordered, not just the fact that it is ordered.
And so the general process is since you got a lot of states, you just don't have true or false. You're going to need to fingerprint all these states in the first place to see that when you're going to do your injection, in what state match what case. So you got a first step of like doing a fingerprint of everything. What you can do is just a basic MD5 of the page So when you're injecting after that to retrieve information, you just compare your MD5 and you see, oh, it's the same page or it's not the same page. And you can use, to generate all these states, you can use the case statement in MySQL, for example. It works in other database as well. So you will have, here you got your request. This is a basic one. Select the version. And depending on what the first 2 bits are, you will order by a different column every time. And so when you get the response, you will be able to see, oh, it ordered by the column number 3, so the 2 bits are at 2. So this is what it looks like. And so you're doing 2 times the request. So here you're retrieving 2 bits of information, and here you're retrieving 2 other bits. So every time you do 1 HTTP request, you get 4 bits of information. So you're 4 times faster than any tools you can actually find on internet.
But yeah, everyone's only really looked into using like columns for ordering there. But if you check the manual, you have another option there. Instead of using a column name, you can use the rand function. So I looked into that a little bit, just saw how it worked, and so basically, that's your default state. You have it's all the results. You order by rands. You'll change the order of the data. Run that again. You'll get another order. It'll change because the seed's generated for you. It's changing. It'll change the order every time you run it. But the rand function in MySQL, you can supply a seed to that. So that's kind of interesting. So if you just apply the seed 1, you'll get that order, and then run it again with the same seed, and it's the same. Makes sense to anyone who understands random number generators. The seed it's a feature to keep the predictability of the random numbers. So like they'll output the same results, and that's the Ruby code
to generate the random value based on the integer e. So it's completely predictable. So since you can predict what the random value will be on the other side, because if you use MySQL on your system, you will generate exactly the same random value. So you will be able to guess how things are going to be sorted on the other side.
Yeah. Exactly the same, 32-bit, 64-bit, which like, it's a feature. Like if it wasn't, then things would break. So it's kind of good. So took it a step further. And yeah, so for that last example, the IDs down the side, when you supply different seeds, you get different orders. So generate an entire list of those until we hit a collision. Like down here you can see we've got 1, 2, 3, which was also up there. So that's when we stop. Yeah, so from there we see that we had 4 until we had a collision. So that means we can get 2 bits of information. It's not all the possible cases. You don't have like every single ordering here. Like you don't have 1, 3, 2. So it's not quite optimal there. But we find with large sets of data, those extra states that you kind of lose doesn't really doesn't matter that much. Like it makes the entire process a lot easier. And you'll see later, like we still get a fair bit of information per request. So yeah, just to understand this, like if you go back here, you see that the order by rand 1 got 3, 1, 2. And yeah, and here again, order by rand with the seed 1, you get 3, 1, 2 again. And yeah, we just converted these numbers to base 2. So using this for the order by rands, this is an example of using the 2 bits. So start with the ifs. Inside here you'd have some subquery that returns 0s 1. So you don't really need, you can return a string and then just convert that to 0, 1. So that's our 2 states there, our 2 checks. We join those together, convert it back to base 10. So then by converting back to base 10, we'll have these seeds again, 0, 1, 2, 3. So we can generate this on our system, and it'll match the vulnerable system as well. It's kind of important. So yeah, here's some more Ruby. Here you take your injection, the information you want to retrieve. So that could be like the contents of a etc. password or MySQL credentials, things like that. And that's just converting it to hex. Because the hex function, you can take a string of any size and it'll convert it to the hex of that string. And there's no limit there. And then the conversion conv function will take it from hex base 16 to base 2. The problem here with conv is that it will cap at max integer for MySQL in that system. So what I actually do in my implementation, I use replace and like manually like change like 0 to 0000 and just create my own conv basically, so that way I can get more bits later on. And then yeah, I just have a loop going on here and just grabbing like I could be grabbing 3 bits at a time and just go to the end base, go to the end. Hard to explain, but so using this, if the table that you're injecting into per request, you can get like up to 17 bits, like even higher, but I don't know.
It's most since it's based on the number of states you can generate. The exploitation really depends on how many states you can generate and how many information you get back from the database on the server side. Because if, for example, you get a big table like in the response with thousands of different states, you will be able to retrieve more and more and more information.
So yeah, we got up to 13 rows. When we hit 14 rows, Ruby starts using a lot of memory, and you're doing like 500,000 requests just to get like 19 bits of information. So kind of look into more like a rainbow table approach here, like pre-generate all this information and have it stored. And then you won't have this big, a lot of processing you have to do at the start. Still looking into the best way to do that, best way to store that. It's kind of surprising how low these are, because really you have a lot of states with 7 rows, all the different ways you could order it. It's mainly just due to how bad and insecure, how not random the random number generator is. Yeah, not many people use it for security, so I guess it's good enough. So yeah, take a real world scenario where you got 7 rows, you can see all of those, the rows aren't paged or anything like that. It's a bit of a limitation, but usually you see a fair few rows anyway. So take 7 rows, looking at the table, and when you generate it, you'll see that you can get 5 bits. So yeah, grabbing etc. password. It's 1,830 characters, which is like 14,000 bits. So SQL map will do like 14,000 requests to try and grab that, which is kind of crazy. So yeah, I can grab that just plain text with about 3,000 requests, but if I compress it and grab it like that, it's only 1,100 requests, so you really do notice the speed. And that's, yeah, like my script doesn't use any like HTTP pipelining or anything like that, but it's still way, way quicker. Here's an example of it running. Yeah, just showing, like it literally grabs like 5 bits of binary the entire way. And yeah, I'm going to throw the source up tomorrow and grab it there if you want. So yeah, that's about it. Any questions?
Can you go back to the GitHub URL?
Yeah, sure. I think we're good. Yeah.
Are you seeing as many SQL injections as you used to? With successful? From the perspective of investigating SQL injections, they're dropping off in our experience. We're interested in the other end of the equation.
I don't think as many people are developing in PHP, so there's probably some correlation there. But like the order-by injections, yeah, like come across those fairly regularly. Like the frameworks that do protect against SQL injection. Lots of people like to rewrite their own ordering type functions, and they do the raw SQL there.
The thing is, as well, with the ordering, if you are using a parameterized query, like in Java, you can't use parameterized query for the order by. You have to fix it in the first query before using parameterized parameters. So what people do, they do everything correctly, except they just concatenate the order by at the beginning. So this is where we really often find vulnerabilities in websites.
No more questions?
All right, thanks.